This is Lab 8 Laser. I'm Owen Litz.
And I'm Richard Fang, and this is for our TA Lam Nguyen.
The goal of this part of the experiment was to align a laser cavity with a mirror to create modes. An external mirror was used to laser the medium as there was no second mirrored surface in the medium container. Once this was done, the medium was excited and used to laze onto the card. The tip and tilt of the external mirror was changed, and this produced visible modes on the cards.
On this side, you can see some of the modes that the laser produced as we changed the tilt on one of the axes of the mirror.
The goal of this part of the experiment was to determine the longitudinal spacing of the output of a helium neon laser. This was done using a Fabry-Perot interferometer. The laser was directed into a sensor that detected its free spectral range and the separation of individual modes.
The FSR is the distance between the periodic larger peaks on the oscilloscope, and the mode spacing is the difference between the adjacent peaks on the oscilloscope. We find that ratio of TFSR over delta nu FSR equals T mode over delta nu mode. Rearranging, we can find that delta nu mode equals T mode over TFSR times delta nu FSR, where we know that delta nu FSR is 10 gigahertz. We are also given the lie procedural equation that delta nu mode equals C over 2NL, where L is the length of the laser cavity. We measured TFSR equals 0.0512 seconds and T mode equals 0.0044 seconds. Thus, plugging these into the equation, we find that delta nu mode equals 859.375 megahertz for the longitudinal mode spacing. And using the given Lie procedure equation rearranging, we can find the length of laser cavity of about 17.45 centimeters. We can also find delta nu mode by using our given equation and measuring cavity length of 0.18 meters. Plugging this into equation, we find that delta nu mode is about 833.33 megahertz, giving us an error of about 3%. And this is some of the screenshots from our oscilloscope data.
For this part of the lab, the spectrum of a helium neon laser and a laser diode were measured. This was done using two mirrors that guided the laser into the detector of the OSA. The spectrum of the first laser has one mode as it is well calibrated. The laser diode has multiple modes as it has a relatively lower quality and is not as well calibrated.
These are the results for our Heaney laser. Find that a primary mode wavelength of 632.85 nanometers, which is about what we expected of 632.8. Primary mode width of 0.0145 nanometers, and there's no mode separation because there's no second mode. For a laser diode spectrum, measured a primary mode wavelength of 651.9979 nanometers, primary mode width of 0.0139 nanometers, and a mode separation of about 0.1725 nanometers.
In this part of the lab, the node frequencies of a helium neon laser were measured. The laser was directed into a sensor that is connected to an electrical spectrum analyzer. The ESA was used to find the frequency of the modes of the laser.
We were able to find two modes at 1749 megahertz and 889, giving us a delta nu mode of 860 megahertz, which we have an expected delta nu mode of 833.33 from the previous calculations, giving us an error of about negative 3.1%. No!